So now we're going to talk about integration by substitution for trig. The good news is it's easy, just like the power rule was. And I kind of say that tongue in cheek, but there's not a lot of formulas you're going to need to know. This is what we learned earlier on in the section 4.1. It's just reverse derivatives. So when you use u substitution for trig, all you're doing is instead of those x's, you're making them, watch this, u's. So no formulas are really, there's no new formulas. It's just sometimes you're going to have to get everything in terms of u. Just like with the power rule, which I'm going to keep up here, because the trig integrals, sometimes they get tricky because you can find them from this list, or sometimes they convert into a power rule, and you'll see that. So let's start. This first trig integral doesn't look too bad, but remember we could only integrate the sine of x dx, and that would be negative cosine x plus c. So this is x over 4. So we have to convert this so it looks exactly like this, sine of u. So we're going to use this exact same method we just used for the algebraic functions. If we want to make this sine of u, we have to let u be equal to x over 4. Now it is sine of u. But just like with the algebraic ones, we also have to find du immediately after, which is the derivative of x over 4. Remember, x over 4 is just 1/4 x. So the derivative of x over 4 is 1/4. Add your dx. So if you want to make your substitutions down here, we just said we need to make x over 4 equal to u. So we can use the formulas. Now dx is actually equal to, you have to multiply 4 on both sides, 4 du. So this would be 4 du. 4 is a constant. So that's all we have. That fits this. Now we can integrate. So the integral of sine of u du is negative cosine of u. So this is 4 times the negative cosine of u. Plug the u back in to get our final answer of negative 4 cosine of x over 4 plus c. So you can see the method of doing this is the same with all the previous functions where they weren't trig, they were just algebraic. So that should be, the process should be, hopefully you're getting very used to it. So the next question looks very complicated until you realize that secant 10x tangent 10x can be easily converted into secant u tangent u with an easy u substitution, and we have that formula. So in this case, so we do have secant u tangent u, we have to let u be tangent x. So du is obviously 10 times dx. So first of all, rewrite this in terms of u. The 9 is a constant. We can factor it out. 10x is u. So now we can use that formula, but you can't forget to substitute for dx. According to this, dx would equal du over 10, and that over 10 is just a constant. You can skip some of these steps. As you're starting to get used to this, you can really go straight to this step. if you're comfortable. And now, as we saw back here, the integral of secant u tangent u is secant u. So this would equal 9 over 10 times the secant of u. Resubstitute the u back in, as always. So the final answer is 9 over 10 secant of 10x plus c. Okay, so one last word on that. You can take the derivative of this. You have to use the chain rule to check, and you will get this. That's not bad practice if you want to try it. I'm going to go to Wolfram Alpha because there's a few things you have to be really careful about in Wolfram Alpha when you're checking trig. You remember those trig identities, and trig functions can be written in a lot of different ways. So sometimes either Wolfram Alpha will give you the correct answer, but it's not the answer you're expecting. I'm not sure what's going to happen here, so we're just checking it. And secant 10x times tangent of 10x. So the first thing I'm going to do is look at my integral and make sure I plugged it in right. And Wolfram is giving me 9/10 secant of 10x plus a constant. 9/10 secant of 10x plus a constant, which is exactly what I got. So I'm happy with that. We're done. But again, the one thing you have to watch out for Wolfram Alpha, we may see that later on, is sometimes the answer they give you is some kind of version of this that may or may not be quickly recognizable. So that's it. The next two examples we're going to do are very important to watch because they're trig examples that actually become a power rule. You'll see.